Most of our universe is unexplored and filled with many nerve-shaking mysteries. One such discovery has been made by the billion-dollar James Webb Space Telescope, as it has found some swirling, gritty clouds on a remote planet. Watch the video till the end as we tell you everything there is to know about this planet. For decades, scientists have been searching for other habitable planets that can sustain life. Found 40 light-years away from Earth, this planet, found by the James Webb Space Telescope, is comprised of silicate cloud structures in its whirling atmosphere. In addition to finding signs of carbon dioxide, the James Webb Space Telescope has found water, methane, and carbon monoxide on the remote planet. This is the highest number of molecules that have ever been discovered at once on a planet outside of our solar system. Named VHS 1256b, the planet was discovered as part of the Webb's Early Release Science Initiative, which aims to revolutionize the scientific community's capacity to define planets and the disks from which they emerge. This planet is of particular importance, as most other study teams have often detected only one feature at a time in each planet. Moreover, no other telescope has ever found that many features on a single target all at once. Before we go further into the details of the planet, it is important to know that the $10 billion James Webb Space Telescope is a joint venture overseen by NASA, the European Space Agency, and the Canadian Space Agency. Launched on Christmas Day in 2021, the James Webb Space Telescope has since provided astounding new insights into galaxies, planets, stars, and several other interesting cosmic phenomena. Within days of the telescope coming online in late June 2022, researchers have discovered dozens of new galaxies that are more distant and ancient than any previously known. Quite interestingly, some of those galaxies are more than 150 million years older than the oldest galaxy discovered by Hubble. The James Webb Space Telescope's real purpose is to explore the universe and our place in it, as well as to solve puzzles inside our solar system and beyond, out at distant planets surrounding other stars. The James Webb Space Telescope is specifically important in the study of exoplanets. If you don't know already, exoplanets are planets that revolve around stars other than our own Sun and are tremendously different in terms of their makeup and climatic circumstances. Exoplanet research can reveal important details regarding the creation, evolution, and potential for habitability of planets in the universe. They can be studied using the James Webb Telescope's array of scientific tools, which can be used to explore a variety of phenomena. Coming back to VHS 1256b, along with identifying silicate cloud structures in the planet's atmosphere, the James Webb Space Telescope observed that during its 22-hour day, the atmosphere of VHS 1256b is constantly rising, mixing, and flowing, pulling hotter matter downward and pushing colder material to the surface. As the accompanying brightness variations are so abrupt, this is arguably the most changeable planetary mass object to date. Using Webb's data, the scientists' team also learned that the planet orbits not one, but two stars during a 10,000-year time period. Thanks to its considerable distance from our planet, the researchers were able to directly view the VHS 1256b instead of using the transient technique or a chronograph method to collect this data. Enjoying the video? Make sure to let us know in the comments section below what you think about the James Webb Space Telescope and its features. Interestingly enough, VHS 1256b is a perfect target for Webb, since it's nearly 4 times as far from its stars as Pluto is from the Sun. On the planet, temperatures rise to an oppressive 830 degrees Celsius or higher in its atmosphere. Moreover, the James Webb Space Telescope discovered that the silicate dust particles of various sizes lie within those clouds, which are displayed on a spectrum. The bigger silicate granules may resemble very hot, very little sand particles, and the finer grains may resemble tiny smoke particles. The VHS 1256b has a low gravity as compared to the more massive brown dwarfs, which allows its silicate clouds to form and persist higher in its atmosphere, where Webb can detect them. Apart from this, the age of VHS 1256b is another factor contributing to its tumultuous sky. The planet is rather new in astronomical terms and came into being only 150 million years ago. So there is no doubt that over the course of next light years, it will continue to evolve and cool. The NASA team views these results as the first coins discovered in a field of study that is thought to contain a wealth of information. The Near-Infrared Spectrograph, aka NIRSPIC, and the Mid-Infrared Instrument, aka MIRI, collect data known as spectra that were used to produce these findings. MIRI was created as a result of a 50-50 collaboration between NASA and ESA. While the U.S. efforts for MIRI were led by NASA's Jet Propulsion Laboratory, the ESA's contribution comes from a global alliance of European astronomy institutes. Their precise measurements of a planet 40 light-years away shows how significant the James Webb Space Telescope will be in the near future. It's worth mentioning that the Webb's incredible initial images are taken with the help of an infrared technology, which gives us a glimpse into the past. This is particularly important as this wavelength is invisible to the human eye and can detect the weak light emitted by aging stars and galaxies. Furthermore, the telescope can collect enough light from astronomical objects to reveal their composition and travel through space, including young stars and exoplanets. With these features, the James Webb Space Telescope is already beginning to reveal the atmospheric composition of planets hundreds of light-years away from Earth, offering hints as to whether or not they might be able to support life as we know it. As Webb is an infrared telescope, it also has the benefit of seeing through dust to find things that Hubble and other telescopes were not able to see. One of the biggest examples of this is the image of two galaxies merging, captured by the James Webb Space Telescope. Quite unsurprisingly, we have not heard the last about VHS 1256b, as this is just the beginning of a massive modeling effort to suit Webb's complex data. The researchers leading this discovery have also published their findings on the VHS 1256b in the Astrophysical Journal Letters under the title The James Webb Space Telescope Early Release Science Program for Direct Studies of Exoplanetary Systems 2, a 1 to 20 micron spectrum of the Planetary Mass Comparison VHS 1256 to 1257b on March 22nd. As this team and others continue to sort through the Webb's high-resolution infrared data, there will be a ton of stuff to learn about VHS 1256b in the coming months and years. All in all, this discovery is of huge importance because it sheds light on the atmospheric dynamics of exoplanets and their potential for habitability. Well, that's it for today. We hope you enjoyed the video, and if you did, show some love and hit that like button. And don't forget to subscribe to our channel so you never miss out on any of the amazing videos we have in store for you.